Okay, let's just start with a question. Is this the only universe? It sounds simple, right? But it might just be the most profound and, honestly, unsettling question in all of modern science.
So today, we're diving into the multiverse, a concept that really pushes the boundaries of what we even call reality. And the wildest part? This idea doesn't come from some sci-fi movie. It comes from the very heart of theoretical physics.
At its core, the whole multiverse theory offers up a pretty radical answer to that first question. It suggests that our entire known universe, that's not the whole story. Not even close.
I want you to imagine our universe as just one single bubble, floating in this vast cosmic ocean that's just filled with countless other bubbles. And these other universes, well, they could have their own unique laws of physics, totally different timelines, completely different versions of reality. Some might be almost identical to ours, while others could be, well, impossibly alien.
So where does an idea this mind-bending even come from? It's not just a random guess someone threw out there. In fact, we're going to explore 3 separate scientific theories that, believe it or not, all lead physicists to the very same startling conclusion, that we are part of a multiverse. All right, our first path starts right after the Big Bang. We know our universe went through this period of super fast expansion called cosmic inflation. But here's the really interesting part. Some physicists think that process never actually stopped. Not everywhere, anyway. In this model, you've got this background of space that's just eternally inflating. But in some pockets, that expansion slows way down. And that allows a stable universe like ours to form. This could be happening constantly, just churning out an infinite number of these separate bubble universes, all totally real, but forever beyond our cosmic horizon, beyond anything we could ever hope to see. Okay, path number 2. This one comes from the deeply strange world of quantum mechanics. See, on the tiniest scales, reality isn't fixed. It's more like a cloud of probabilities, waiting for an event to happen and for one outcome to be chosen. But what if every outcome happens?
Yeah, this interpretation suggests that with every single quantum event, reality itself physically splits. It branches. A whole new universe is created for every single possible outcome. And unlike those bubble universes, these parallel timelines might be right here, occupying the same space as us, just vibrating on a different plane of existence, forever separate, forever unable to interact.
Now for our third path, this one is maybe the most abstract of all. It starts with this really radical idea from some physicists. What if mathematics isn't just a tool we use to describe reality? What if mathematics is the fundamental reality? If that's true, it leads to a staggering conclusion. If you can describe a universe, any universe, with any set of physical laws or dimensions, with a consistent set of equations, then that universe has to physically exist somewhere. From this point of view, our reality isn't special at all. It's just one of the infinite mathematical structures that just so happens to be stable enough for life like ours to show up. So if any of these theories are right, what does it actually mean for us? This is where the physics starts to get deeply personal. And, let's be honest, a little bit unsettling. Just think about it. If there are infinite universes, then the laws of physics we cherish aren't universal truths. They're just local bylaws. Our universe doesn't need some special design for life, because with infinite chances, a life-friendly universe was bound to happen. It means that everything that can happen does happen somewhere out there. And, maybe the most disturbing question of all, what does that mean for our own uniqueness if there are infinite versions of us? This quote just brings it all home, doesn't it? The idea that there are countless versions of you, some living out your wildest dreams, others who made different choices, maybe tragic ones, and none of them have any idea that the others exist. Now, as incredible and mind-blowing as all this is, we've got to ground ourselves back in scientific reality. There's a huge reason why the multiverse is still a really controversial topic for physicists. And here's the bottom line. By their very definition, these other universes are completely beyond our reach. We can't see them, we can't measure them, we definitely can't run experiments on them. And this creates a fundamental problem for the scientific method. You see, science is built on evidence, on hypotheses that you can actually test. But the multiverse, right now, sits outside that framework. It's a conclusion that comes from our best theories, sure, but it's not one we can directly prove. And this has led to a massive debate. Has physics crossed the line into philosophy here? So if we can't test it, why do scientists even spend so much time on it? Well, because even if it's just a hypothesis, it forces us to confront our most basic assumptions about what reality even is.
I mean, think about the history of science. It's consistently shown us that we are not the center of things, not the solar system, not the galaxy. The multiverse is just the ultimate extension of that idea. It challenges us to think, what if our entire reality is just an insignificant, random blip in a much grander, infinite existence?
And that brings us to our final lingering question. If these other worlds are real, are they sealed off from us forever? Or could there be some way for information to pass between them? Is reality fundamentally locked, or are there maybe some cracks in the walls between worlds? We'll dive into that when we explore quantum reality and the limits of our knowledge in our next explainer.